All right, so this is lesson 4.4, and this lesson is still on radicals, and we're going to have exponential radicals today. So we have two new exponent laws. So the base is x, so that's going to go under the radical. The denominator is the root index, and the numerator is the exponent. And really you don't need the 1 there since it's a 1. Just implied that it's there. All right, there's actually two ways you can write this if there is a fractional exponent. So no matter what, the denominator is the root index, and the numerator is the exponent. That's one way to write it. Or you could write it like this still. I mean, no matter what, the denominator is still the root index, but the exponent could also go on the outside like this. And I guess it depends on what the question's asking, which way you write it. All right, so I'm going to change from radical form to exponential form. So I'm going to maybe get rid of this one and get rid of this one, I guess. So 3 is my base, and then the root index is the denominator. So this is going to be 3 to the 4 fifth power. And then this one I want to do the opposite. I have exponential form and I want to write it in radical form. So 2 is my base, the denominator is the root index, and then the numerator is the exponent. So that's how you go from one form to the other. Okay, just a refresher. No matter what, if you have a positive number under a radical, you're going to get a positive answer. If you have a negative number underneath, it does matter. So if you have an odd root index, you're going to get a negative answer. If you have an even root index, you're going to get an imaginary answer. That's just a little refresher. Okay, so this is going to be no calculator. So what I'm going to do is I'm going to cross off 6 and 8 just to keep it kind of going here. Okay, so the first thing I want to do is, in order to evaluate without a calculator, I want to rewrite this in radical form, since it is no calculator. So I got the 4th root of 81, and then I'm going to cube my answer. So since I'm evaluating, you probably want to put the numerator as the exponent on the outside. It's going to be easier that way. Now this is where you need to use this paper that I'm going to give you. So I guess I'll have to maybe put this on Schoology so you can look at it. Anyway, so I'm trying to figure out what number to the 4th power is 81. Here we go, right here. 3 to the 4th power is 81, which means the 4th root of 81 is 3. So this becomes 3. And then I'm going to take 3 cubed, so 3 times 3 times 3 is 27. Okay, number 9, first I'm going to rewrite it. So I got the 4th root of 16 over 81, and then I'm going to cube all of that. So I'm trying to figure out what number to the 4th power is 16. That is 2. And then we already figured this one out from above. This is going to be 3. And I'm going to cube that. So 2 cubed is 8, and 3 cubed is 27. You have to make sure you cube both the numerator and the denominator. So again, the way I got 2 is I wanted to see what number to the 4th power is 16. Here we go, 2 to the 4th power is 16. Okay, moving right along here. All right, let's take a look at some negative exponents. So let's ignore 11, and then we'll do 10 and 12. Okay, so number 10, first, again, I'm going to rewrite it. Okay, now I have to decide, since I have a negative underneath, if I'm going to pull out a negative or if I'm going to pull out an I. Since this is odd, I'm going to pull out a negative. that is now positive. Oh, sorry, that doesn't go there actually. It goes right here, out in front. It's my bad. Okay, so I pulled out the negative, I made it positive. Okay, so now I'm going to do the cube root. So I'm trying to think, what number to the third power is positive 125? Well, that's 5. And then what number to the third power is 64? That's going to be 4. And then I have a negative out in front. And I'm going to square it. I'm going to square both of these numbers. So negative 5 squared is 25. And then 4 squared is 16. So that is my answer to number 10. Okay, number 12. Now I'm getting into negative exponents. So what you might want to do first is, since you do have a negative exponent, maybe go ahead and flip your base and then make your exponent positive. Now you don't have to worry about it. Now we're going to rewrite it. And then to the fourth power. Okay, so I'm trying to figure out what number to the third power is 125. That's 5. And then what number to the third power is 64? That is 4. And then I'm going to take them both to the fourth power. So that's where, again, you're going to find all these answers on this blue sheet. So 5 to the fourth is 625. And then 4 to the fourth is 256. So 625 over 256. All right, moving on. Okay, it looks like I'm going to cross off number 16 because that's just like 15. Okay, so on 13, the first thing I probably want to do is, now this time it says to simplify. It doesn't say to evaluate. Evaluate means I'm actually going to be able to get an answer. But simplify means I just want to simplify it until I can't go anymore. So, first of all, I want to do my exponent rules. So if I have the same base, I'm going to add my exponents. So I'm going to get 81, and then if I take 1/8 plus 1/8, that's 2/8, but that reduces to 1/4. And then I got 3 to the 3/4. Now, there's nothing I can do yet because my bases are different. If my bases were the same, I would be able to subtract my exponents, but I can't do that. So I'm going to have to change 81 to a base of 3. So let me look at my paper. I'm looking for all the 3's. So 3 to the 4th is 81. So if I change 81 to 3 to the 4th, and then leave everything else the same, that's a good starting point. Okay, now I'm going to have a power to a power, so I'm going to multiply. So 4 times 1/4, that's just 1. So I got 3 to the 1st, and this is 3 to the 3/4. Okay, now they have the same base. And since they have the same base, I can now subtract my exponents. So 1 minus 3/4 is 1/4. Now that's as far as I can go, because if I were to rewrite this as a radical, I can't take some number to the 4th power and get 3. So I can leave it just like that. I mean, I guess you could write this as your answer. That's fine as well, but there's really no need. Okay, 14. So I'm going to I'm going to get rid of my parentheses first. So I'm going to multiply the exponent. So I'm going to get 3 to the -6/3, which is -2. And then I'm going to take 2/3, same thing, -2. So I went ahead and just multiplied the exponents. This is like saying 3/1. Okay, well, this is the same thing as 1/3 squared. This is the same thing as 1/4, or I guess I skipped a step, 2 squared. This is going to be 1/9 times 1/4. So my answer is 1/36. So that is my answer to that one. Now this is probably the hardest lesson out of all these, all of them in chapter 4, but to be exact. Okay, 15. Okay, I'm going to rewrite these in exponential form. It's just easier that way when it says to simplify, to put them in exponential form. So this is 5 to the 1/2, because remember there's a little 2 there, and this is 5 to the 1/4. Okay, my base is going to stay the same, and I'm going to take 1/2 minus 1/4, which is 1/4. And that's as far as I can go. I guess you could write it as a radical if you want, but you don't have to, since it means the same thing. Okay, so that's one part of chapter, or lesson 4.4. Okay, now we're going to switch gears and we are going to do domains. There are a couple things you want to keep in mind, which what I'm about to write, it is all of this, but I'm going to go further. I'm going to kind of summarize. First of all, if you have a denominator, if you have a fraction. If you have a fraction, then your denominator cannot equal 0. That's one thing you need to look for. Second one thing you want to look for is if you have an even root radical. If you do, then the stuff underneath must be greater than or equal to 0. The third thing you want to look for is if you have both of these together. So if you have a fraction and an even root radical in the denominator, the stuff underneath must be greater than 0. Okay, so that brings us to 17, and we're not going to do all these. We'll be skipping around. All right, 17. If I look at the things I just wrote down, I don't have a fraction or an even root radical. So since it's none of these, my domain is all reals. Number 18. Okay, this time I have a fraction. So my denominator, which is x plus 2, cannot be 0, which means x cannot be -2. So that's my answer, because all of this is not allowed to be 0. If x was -2, then that would be 0. Okay, moving on to 20. This time I have a radical with an even root index. That means the stuff underneath has to be greater than or equal to 0. So I'm just going to solve for x now. So I'm going to add over the 1, divide by 4. So my domain would be x is greater than or equal to 1/4. Okay, 21. I do have a radical, but this is odd. It doesn't say anything up here about that. So it's all reals. Okay, 22. I have an even root there. So the stuff underneath must be greater than or equal to 0. And then after you decide which one of these that it is, you just have to solve for x now. Now this time it's an x squared. So this is something else you might want to make a note of. If you have an x squared, then you're going to have an absolute value of x in your answer. So I'm going to add over the 25, and then I'm going to take the square root. However, since that's an x squared, I want to change it to this. So this would be my answer. Okay, moving on. Okay, this time I have a fraction and an even root radical. So the stuff underneath, which is 3x minus 6, must be greater than 0 because it's a fraction and an even root radical, like it says right here. So now I just got to solve for x. So first I'm going to add over the 6 and then divide over the 3. So that's my domain. Okay, 24. I do have a fraction, but this is an odd root radical. So whenever it's odd, I don't care about this being a radical. I only care that it's a fraction. So the stuff underneath just cannot equal 0. Again, I don't care that it's a radical because the root index is odd. I only care that it's a fraction, which means x cannot equal -5. Okay, let's look at 26. I have an even root radical, so the stuff underneath must be greater than or equal to 0. So once I figure out what symbol I'm using here, based upon the 3 restrictions, you solve for x. So first we're going to subtract over the 4. I got to multiply or actually divide by a -1. Now if I do that, my sign flips. And now I take the square root. However, if there's an x squared, I have to put the absolute value of x in my answer. So this is my answer to that one. All right, let's go down and look at number 30. Okay, 30 I have a fraction, but I also have an absolute value, which it doesn't say anything in my rules about having an absolute value. So actually on 28 is all reals because I don't have any restrictions for absolute value. So on 30, I only care that this is a fraction. So just the denominator, which is x minus 1, cannot be 0. And then if I get x by itself, x just cannot be 1. It can be any number except for 1. Okay, let's look at 31, and then I think that should be good. So I have an even root radical. Now this one we're going to think about for a second. I want the stuff underneath to be greater than or equal to 0. Well, if I subtract -2 and then take the square root, I'm going to get an imaginary number. That should be a red flag. So I have to go back up and think about this for a second. So it just can't be negative. Well, this happens to be all reals. This is never going to be negative because if I square any number, whether it's positive or negative, that's a positive. And if I add 2 to any positive number, it's still going to be positive. So any number is going to work on this one. Okay, so that is that. So again, this lesson is probably more challenging than the others. But if you need to rewind and listen to what I said on a specific question, go for it.